cross-canceling is the key thing is it's based on the idea that anything times 1 is itself. So any unit, so we could have 5 times 1 is 5. We could have 1/2 times 1 is 1/2. And we also combine that with how to multiply fractions in general. So let me show you what I mean. So let's say we have 1/2 times 1/5. Now, if this is the first time you're coming back to fractions, or even the first time you're learning about fractions, take your time with this. This is not like usually the first thing you learn about fractions. We have to understand what 1 out of 2 means, what 1 out of 5 means, and we want to understand how equivalent fractions work. So if I lose you here, do not worry, you can let me know. We're going to come back to this, of course, but just working based on this understanding. So we're going to start with multiplying fractions, and what we do in general is to just multiply straight across. So the stuff on top, so 1/2 times 1/5 is 1 times 1, which is 1 over 2 times 5, which is 10. So half of 1/5 is 1/10. Okay, in general, we just multiply straight across. So we could do the same. 3/7 times 4/9 would equal 3 times 4 on the top is 12. 7 times 9 across is 63. Very good. And now the difference between this question and this question, though, is that this answer, 1 out of 10, cannot be simplified any further, but 12 out of 63 can be reduced. So this is where we want to understand simplifying fractions and what equivalent fractions mean. So in this case, we can actually divide a 3 into the top and the bottom. So what I mean by that is 12 can be written as 4 times 3, because 4 times 3 is 12. And 63 can be written as 21 times 3. You can confirm that if you need a little more time, that's okay. 21 times 3 is 63. So because there's a 3 here and a 3 here, I can actually kind of undo this multiplication process by writing it as 4 over 21 times 3 over 3. And 3 over 3, or anything over itself, is 1, because we have 3 parts of 1/3, right? So that's why we want to understand what fractions mean. 1/3 is taking a whole unit, a 1, dividing it into 3 equal parts, so that each part is 1/3. But we have 3, the top, the numerator, tells us how many of those 1/3 we have. So if we have 3/3, we actually have a whole 1. So if this thing is 1, then 4 over 21 times 1, or like we said, anything times 1 is itself. So this is actually equal to just 4 over 21. So that means that this is equivalent to this. So you may have learned the rule that if you can just come up with numbers or factors that go into both the top and the bottom, you can just divide them and cancel them out. Really, where that comes from is this. It's to factor and then undo the multiplication, because we said multiplying fractions is just multiplying across the top and across the bottom. So if I have this, I can split it back out. So I can split out the 3 over 3 into 1 to get something equivalent. Or you could just look at this and say, oh, 3 goes into both the top and the bottom. So boop, 4, boop, 21. And as you get more practice, you'll be able to do that a bit quicker. So the idea of cross-canceling is actually kind of similar to that. It's a shortcut for us to be able to look at these factors while this, instead of multiplying across straight away and then simplifying, we can kind of simplify as we go to get a directly simplified answer. So in this case, we would check across, canceling across. And of course, if you actually have something like 3 over 6 that you can simplify, like as in itself, you can also simplify it first if you want. So this is where we can look across, or we can look up and down. But cross canceling is about looking at the top of this one and the bottom of this one, the top of this one, the bottom of this one. And what we do is we try and see if there are any numbers that go into both. So in this case, we look at 3 and 9. So we know that 3 goes into both 3 and 9. So 3 goes into 3 one time, and 3 goes into 9 3 times. So we cancel, and we leave a 1, and we leave a 3. Okay, so if we were to visualize what's actually happening there, we're really just writing 1 times 3 times 4, like that, over 7 times 3 times 3. And then we see we have a 3 on the top and the bottom, or maybe this 3, it doesn't matter which one, we're just going to cross out one of them like that. So we're left with the 1, and then we're left with the 3. So when we cross off the top and the bottom, we don't have to write it every single time, but you can visualize that as writing 1 times 4 over 7 times 3 times 3 over 3, just yoinking that out to the side. And order does not matter because multiplication is commutative, so we can swap the orders here within any pairs. So that's a useful kind of little trick there, just to build some intuition about why we're able to cross out top, bottom, side, side, and like that, because we're basically undoing this multiplication process and pulling out multiples of 1 or factors of 1. So instead of just memorizing the rule or the trick or whatever, it can be cool to think about. I hope so anyway. But if you want to just go into 3 and 3, just cross them, then you can check 4 and 7. Nothing goes into both of those, so we're good. And so then we have 1 times 4, so you proceed multiplying with the top over bottom. So 1 times 4 is 4. 7 times 3 is 21. And so we still get our answer 4 over 21. And assuming that we actually simplified, or we cross-canceled everything that we possibly can, so you'll want to check across, and you'll want to check like up and down still, so 1 and 7, 4 and 3 are good, 7 and 4 are good. Assuming that you have every pair that's clear and no other common factors, our answer is going to be simplified, so you don't have to check that anymore. If you really want to take it to like the core root level, you can actually prime factorize everything. So this would be 2 squared, this would just be 7, this would be 3 squared, this would be 3. Because if we go to our prime factors, then we can't break that down any further, and we can just cross out however many overlaps we have. But that's only if you can't figure out like what the greatest common factor is, and we actually have a video on how to find the greatest common factor between two numbers. So the fractions could be way bigger, but that's not as common. So that's the general idea. Maybe we can do one more on the board together before we just pop it down and just work through a whole bunch. So let's say we have, I'm just grabbing one here, but we might end up doing it again. But let's say we have 8 over 12 times 1 over 10. So this is where it's just fun. You don't have to do it any particular way, just whatever you want or whatever the instructions say. But you can look between 8 and 10 like this diagonal for the cross canceling, but you might also notice that 8 over 12 can actually be simplified. This fraction, 8 over 12 times 1 over 10, this could be simplified because 4 goes into both. So as long as when you cross, you're keeping track of what you're dividing by, or just which way you're dividing, helps, you can go ahead and rewrite that out so you can see what you're doing. And then we can check across. So 2 and 3 are good, 1 and 10 are good, but 2 goes into 10, or 2 goes into 2 and 2 goes into 10 rather. So it's not just that 2 goes into 10, you want to look for common factors that go into both. So if this were, let's say, 4, you would say 2 goes into 4 and 2 goes into 10. So we're looking for common factors. So that means that 2 goes into 2 and 2 goes into 10. So 2 goes into 2 1 time, 2 goes into 10 5 times, and that's it. And then 3 and 1, only 1 goes into both of them. So that's fine, we don't cancel anymore. So we have 1 times 1 going across over 3 times 5, which is 15. And again, if everything is simplified and we crossed out everything we can, our solution should be simplified and we don't have to look at it anymore. But just to show that that is indeed equivalent to our answer, if you really don't remember how to do cross canceling or simplifying, you can always default to just multiplying across. So that would be 8 times 1 is 8 over 12 times 10 is 120. Although at this point we would still have to know how to simplify, but you might notice that you might, divide by 2 on the top and the bottom. So you had 4 over 60, just assuming that we can't recognize that 8 goes into 120. That's kind of an oddball one, but 4 goes into 60. So you can just do this one step at a time. You could divide by another 2, so get 2 over 30. Divide by 2 again, it's 1 over 15. So we'd still get 1 over 15. So don't worry about that too much. Just divide however you can. These are all equivalent fractions, but we can talk about that more directly another time. But just know that as long as you divide by the same number on the top and the bottom, you get an equivalent fraction, or multiply by the same number on the top and the bottom. Again, because of the multiplying by 1 and how multiplication of fractions work. So that's the idea of cross-canceling, multiplying factors. You could have also divided by 2 on the top here and this one, so the cross-canceling here first before doing the top and the bottom here. So the order of that doesn't really matter at all. Have fun with it, don't worry about it. And so now we're just going to, I guess, chill and whiz through some of these questions. If you're getting a bunch wrong, don't worry about it. There's no grades here or anything, but if you do need extra help, let me know. Otherwise, I'm just going to pop through and factor and cross cancel some, so I might move a little bit quicker. But take your time, and if this is super boring, that's also the idea too. If this is really boring for you, feel free to just close your eyes. We're just here to chill, so don't feel like you have to pay attention. I won't get mad if you fall asleep or anything. Feel free to just zone out or do whatever you want to do. So I just hope that this buzzes you however you need it, and I love you, and let's do some practice. Okay. Okie dokie, let's see what we can come up with here. Let's just have a little bit of fun. We'll just run through these and see how far we get. So we have multiplying fractions with cross-canceling. Okay, so let's fill in our name first. I have some bright fun colors to work with, but let's see, we have name, decaf, teacher, you, score, doesn't matter, and let's see, date, today. Okay, so we are ready. So we cross-canceling, or we can keep in mind that we can simplify fractions as well from top and bottom. So we will just do this however we can. So 11 and 21, there's nothing that goes into both of them besides 1, which I was kind of taking as given, by the way, in my explanation. I realized I didn't really say that out loud much, but I kind of assumed. So if there's nothing that goes into an 11 and 21 besides 1, then we're good. We're not going to cancel anything. But for 2 and 16, 2 goes into 2 and 2 goes into 16, so I'm going to cancel that. 2 goes into 2 once, 2 goes into 16 8 times. Perfect. And 11 and 8 have nothing in common besides 1, and 1 and 21 is all good. So we're just going to multiply straight across. 11 times 1 is 11. 8 times 21 is, I guess we can write it to the side if we need to. But sometimes it's fun to try mental math. So we can do 20 times 8 and then plus an 8, or we can just do this. 8 times 1 is 8. 8 times 2 is 16. So 168. That would be our answer. And since we checked across and we checked up and down, top and bottom, we don't have to check this anymore. It should be simplified. Very good. Great. So now 15 over 20 times 8 over 26. This is number 2. So 15 and 26 don't have anything in common besides 1, it looks like. And 8 and 20, 4 can go into both of those, but I'm also noticing 15 and 20 have 5 in common, so we can just do it however we want to do it. But let's try 4, just for the sake of cross-canceling. So 4 goes into 8 2 times, 4 goes into 20 5 times, and 5 goes into 15, so 15 over 5 is 3 over 1. So we have 3 over 1 times 2 over 26, but then 2 goes into 2 and 26, so this would be a 1 and a 13. So that was a lot of canceling. 3 times 1 across is 3 over 1 times 13 is 13. So 3 over 13 would be our answer here. And if it gets to be like, 2-step cross-canceling like this and it's just too much, we can always just rewrite it again on the side if needed. So that is up to you. And just because there were quite a few steps, I'm actually going to check this by simplifying this way as well. So 15 over 20 is the same as 3 over 4, and 8 over 26 is 4 over 13. So indeed, we cancel out the 4s. We still get 3 over 13. Perfect. Alrighty, very good. Number 3 already. So 7 and 14. Well, 7 goes into both. So 7 goes into 7 1 time. 7 goes into 14 2 times. 12 and 10 have 2 in common. So 2 goes into 10 5 times. 2 goes into 12 6 times. And 6 over 2 is 3. So I could do 3 over 1. So 3 times 1 is 3. 1 times 5 is 5. So we get 3/5. 3/5 indeed. Very nice. So we're having fun. Not worrying too much at all. So number 4, 12 over 26 times 4 over 5. 12 over 26 times 4 over 5. So let's get rid of a 2 here. 2 goes into 4 twice. 2 goes into 26 13 times. And that looks like all that we can cancel. So 12 times 2, 24. 13 times 5. 5 times times 1 is 5 plus 1 is 6, so 65. And that's it. Just like that. Very, very good. Nice job. Let's throw in a little bit of green here for some fun, shall we? So, let's see here. 5 and 4, nothing. 1 and 24, nothing besides 1. 5 and 24, nothing. 1 and 4, nothing. So we just multiply right across. 5 times 1 is 5. 24 times 4 is a 96, I believe. 4 times 4 is 16. 4 times 2 is 8, plus 1 is indeed a 9. 5 over 96. 5 over 96. Very good. Very, very good. It's as simple as that. Sometimes we cannot cross cancel, and that is totally fine. It's just a little shortcut sometimes. So 7 and 22, nothing. 1 and 16, nothing. 7 and 16, nothing. 1 and 22, nothing. So we just go ahead and multiply across. 7 times 1 is 7. 16 times 22, I have no idea. So we're going to do a little double digit multiplication. 16 times 2, well, 2 times 6 is 12. So then we do a little doop for the 1. 2 times 1 is 2, plus 1 is 32. Then we have 12 again, but we have to put a 0 for this 2. 2 times 1 again is 2, plus 1 is 3. 352. Sort of scrap work is kind of going all over, but 7 over 352. Hopefully that is correct. And since we checked across and we checked up and down, we don't have to worry about simplifying this anymore. Very, very good. And we're just getting started. Number 7, 5 and 12, 7 and 22. So 5 and 22 have nothing in common besides 1. 7 and 12, same thing. Notice 5 and 7 are prime numbers too, so that's kind of convenient to check. 5 and 12, 7 and 22, nothing. So we're just going to multiply straight across. 5 times 7 is 35. Whoops, running into the other one. 12 times 22. Looks like we're getting a little bit of practice with double digit multiplication. That's totally fine. 2 times 2, 4. 2 times 1, 2. Nothing we can't handle. We throw in a 0. 2 times 2, 4. 2 times 1, 2. Add it away. 264. And that is it. That is it, my friend. Very good job. 35 over 264. Great. Having fun. 16 over 18 times 3 over 4. So 16 and 4. 4 goes into 4. 4 goes into 16. Let's divide that away. 4 goes into 4 once. 4 goes into 16 4 times. 3 and 18. 3 goes into 3. 3 goes into 18. 3 goes into 3 once. 3 goes into 18 6 times. And then we have a 4 over 6. 1 over 1 just goes away. 4 over 6. 2 goes into both of those numbers. 2 goes into 4 twice. 2 goes into 6 3 times. And we are left with just 2 times 1. 2 over 3 times 1. 3. And that is it. That is it. Very good job. You're getting the hang of it. Cross canceling. Great. So now we have number 9, 20 over 22 times 18 over 21. 20 and 21, nothing in common besides 1. How about times 1, 9. 10 times 10, 100. Very good. 6 and 25, nope. 6 and 7, nope. And 6, 7, nope. 625, nope. So we just multiply straight across. 6 times 6 is 36. 7 times 25, I have no idea. And so 5 times 7, 35. 7 times 2, 14, plus 3, 17. 175. There we go, there we go, there we go. Very, very good, 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 good. Number 12, already. So 3 over 16, nothing. 3 and 8 is nothing. 3 and 16, 3 and 8, nope. Just multiply right across. 9 over 128. That's just a little mental math for us. Let's test that out. 16 times 8 is 48. 6 times 8 is 48. 8 times 1 is 8 plus 4 is 128. So 9 over 128. We're moving along, moving along. Let's see here. 11, 15. Nothing. Those are 11's prime. It's cool to keep in mind. 2 and 5. 2 and 15. 11 and 5. No common factors there, so we just multiply across. 11 times 2, 22. 15 times 5, 75. And if we need to write it out on the side, that is okay. 15 times 5, 5 times 5 is 25, but the little 2 up top, 5 times 1 is 5 plus 2, 7. And that is all. Very good. Doing great, doing great, doing great. 11 and 9, nothing. 3 and 24, I see a 3 that goes into both. 3 goes into 3, 1, so 3 goes into 24. 8 times 11 and 8, 1 and 9, nothing. 11 times 1 is 11. 8 times 9 is 72. 11 over 72 is our answer here. Cool. Alrighty. And then here, 18 and 18. Plop, plop, just go away. That's kind of nice. You don't have to write the ones if you don't want to. But 18 goes into each. 18 goes into 18 once. 3 and 25, nothing. So that is it. Very nice job. 3 over 18 times 18 over 25 is 3 over 25. As though it's just diagonal. Look at us go. Look at us go. Next thing you know, we already did 15 of them. Are you getting the hang of this? Alrighty. Let me know, of course, if you have any questions at all. But we're just hanging, getting through all of the problems. 5 and 20. I see a 1. I see a 4. 3 goes into both 9 and 6. So I see a 3. I see a 2. Multiplying across, 3 times 1 is 3. 4 times 2 is 8. And 3 and 28, nothing. 27 and 4, nothing. So we just multiply right across. And as a little challenge for mental math, 3 times 27 is 81. 4 times 28, about 32. 112. Let's try that. 28 times 4, so that's 32. 4 times 2 is 8, plus 3 is 11. That's it, that's it. Let's see, 330, so I see a 1, I see a 10, 7 and 10, so that's a 7 over 10 times 10, 100. Very good. Let's see, 3 and a 6, so 3 goes into 3 once, 3 goes into 6 twice, and so 3 over 20, multiplying straight across. 5 times 1 is 5, 8 times 3 is 24, no cross cancelling there, because 5 and 3, 1 and 8, nothing, 5 and 8, nothing, 1 and 3, nothing. And we're moving right along. Zippity-doo-dah, zippity-doo-dah, da-da-da-da-da. 5 times 1 is 5. 14 times 24. I don't know. So 4 times 4, 16. 4 times 1, 4 plus 1, 56. Plop that away. Add a little 0. 2 times 4, 8. 2 times 1, 2. Do a little adding. 13, 3, 36. 3, 36. We're zipping through, my friend. So 7, 3, 14 over 2 times 13, 39. And 4 into 16 is 1/4. Nothing else. Oh, 3 and 3 just goes away. Wow, this whole thing is 1/4. That was a nice one. Just cancels with multiple steps. Very cool. 2, 14, 1, and 7. Nothing else, so 6 over 49. Nice. Let's see here. 2 and 4. Plop down 2. This goes away as 1. 2 and 6 is 1 and a 3, so just a 1/3. Good. And let's see. How about just a 7 over 30 straight away? Nothing to cross cancel. Cool. And 2, 9. That's it. 1, 11. 19 over 220. Because we can just do 2 times 11 is 22. Throw in a 0. We're good to go. So 4 and 10, 2 and 5. 2 over 8 is 1 over 4. So we're just left with 1 over 20. And let's do both. So 3 goes into both 9 and 24. So 3 goes into 9 3 times. 3 goes into 24 8 times. And a 4 goes into both of these. So 4 goes into 25 times. 4 goes into 28 7 times. And nothing else. 3 and 7, 5 and 8, nothing. So we just multiply across. 3 times 5 is 15. 7 times 8 is 56. Doing great. How about we run through one more sheet together? I know I'm moving kind of quickly now. Are you getting the hang of this? Alrighty. Let me know, of course, if you have any questions at all. But we're just hanging, getting through all of the problems. 5 and 20. I see a 1. I see a 4. 3 goes into both 9 and 6. So I see a 3. I see a 2. Multiplying across. 3 times 1 is 3. 4 times 2 is 8. And 3 and 28. Nothing. 27 and 4. Nothing. So we just multiply right across. And as a little challenge for mental math, 3 times 27 is 81. 4 times 28, about 32. 112. Let's try that. 28 times 4, so that's 32. 4 times 2 is 8, plus 3 is 11. That's it. Let's see, 330. So I see a 1. I see a 10. 7 and 10. So that's a 7 over 10 times 10. 100. Very good. Let's see, 3 and a 6. So 3 goes into 3 once. 3 goes into 6 twice. And so 3 over 20. Multiplying straight across. 5 times 1 is 5. 8 times 3 is 24. No cross canceling there. Because 5 and 3, 1 and 8, nothing. nothing. 5 and 8, nothing. 1 and 3, nothing. And we're moving right along. Zippity-doo-dah, zippity-doo-dah, da-da-da-da-da-da. 5 times 1 is 5. 14 times 24. I don't know. So, 4 times 4, 16. 4 times 1, 4 plus 1, 56. Plop that away. Add a little 0. 2 times 4, 8. 2 times 1, 2. Do a little adding. 13, 3, 36. 3, 36. We're zipping through, my friend. So 4, 7, 3, 14 over 2 times 13, 39. And 4 into 16 is 1/4. Nothing else. Oh, 3 and 3 just goes away. Wow, this whole thing is 1/4. That was a nice one. Just cancels with multiple steps. Very cool. 2, 14, 1, and 7. Nothing else, so 6 over 49. Nice. Let's see here. 2 and 4. Plop down 2. This goes away as 1. 2 and 6 is 1 and a 3, so just a 1/3. Good. And let's see. How about just a 7 over 30 straight away? Nothing to cross cancel. Cool. And 2, 9. That's it. 1, 11. 19 over 220. Because we can just do 2 times 11 is 22. Throw in a 0. We're good to go. So 4 and 10, 2 and 5. 2 over 8 is 1 over 4. So we're just left with 1 over 20. And let's do both. So 3 goes into both 9 and 24. So 3 goes into 9 3 times. 3 goes into 24 8 times. And a 4 goes into both of these. So 4 goes into 25 times. 4 goes into 28 7 times. And nothing else. 3 and 7, 5 and 8, nothing. So we just multiply across. 3 times 5 is 15. 7 times 8 is 56. Doing great. How about we want to run through one more sheet together? I know I'm moving kind of quickly now. Let me know if you like the quicker math or the slow one. For now, I'm just having fun. Not even worrying too much. Don't worry if you're keeping up. Don't worry if you're not keeping up. If your eyes are getting heavy, just close them. Just sitting here doing our make-believe math homework. 5, 3, 5 over 9. 8, 18 is 4 over 9. Oops, I don't even need to put the bar there. 4 times 1 is 4, 63. 4, 16. Well, we should practice cross multiplying, shouldn't we? So let's look at 4 and 2 then. This goes away. This leaves me with a 2. 2 and 16 is a 1 and an 8 is a 1/8. Very cool. 2, 8, 4, 1, 1, 4, 1/4. 5, 22, 19, 15, nothing. Oh, 1 and 3. Nice. 19 over 66. So about 5 and 14. So 55 over, I don't know, 12 times 14. That's 8, 48, 120, added 168. 6 and 20, we have a 3, we have a 10, give me a 1, give me a 5, we have 3 over 50. We have a 2, we have a 30, so 1 and 15. And how about a 5 that goes into 25 and 15, so 5 and 3. Multiplying across, we have 1 times 5 is 5, 3 times 3 is 9. Zipping, why do I keep saying zipping, dude? Zipping through it, 111. Zip. Zip. 1 over 9 times 16 is 9 times 6 is 54. 9 times 1 plus 5 is 14. 144 indeed. 2, 18, 1 and 9, 11 over 45. That is all. 18, 20, so 9 and 10. And nothing else. So 13 times 9 is what? 117 over 250. 13 times 9, let's confirm that again. 27, 1, 1. That should be it. That should be it. Do you enjoy that? Let me know if you like fast math or slower paced. But you see, we can just go through them. Go through. Do you want to do one more page with not much talking, just some writing? Let's go ahead and do that. 1, 2. This is 5 over 24. 2, 1, 6, cross, 1, 6. 8, 10, 4, 5, 3, and 5, so 12 over 25, 7 over 16, nothing to multiply across there, 1, 4, that's all I'm seeing, 9 over, whatever 28 times 4 is, 32, 11, 112. I hope you're getting sleepy by now. So 2, 7, 4. That's all that we have. So 49 over 64. I insist you're not missing out on anything at all. Oops, here's a 1, here's a 5. We have a 9 over 25. 1, 2. 3, 1, 7, 1 7th. And we have a 3, we have a 4, 3 over 20. Just doing some fractions. Everybody loves fractions. You're doing great. 5, 7, 63 over 125. 2, 6, 1. That's it. 11 over 48. 2, 4, 15. That's all that I'm seeing. So 29 times 4 is 36. 116. Oops. 116 over 225. It's 15 times 15 is 225. Do you remember our perfect squares? Perfect squares. And 2, cross, 2, asleep by now, relaxed, not stressed out about it at all. You're doing a great job. I will see you